Welcome back to my channel, everyone. Sri Tips here, and I've got a little bag of scraps from my friend the jeweler here, and what we're going to do is refine this material for him. And I wanted to say a couple of things while I'm working on this. Number one is that I don't refine other people's material. This is my hobby. And I'm only doing this for my friend, the jeweler, because he is my friend. And number two, I do not offer any kind of training or tutoring services for refining. And another thing is, I do not, people are trying to contact me through my eBay site, and I cannot answer those questions. eBay frowns on using their messaging system for communications because they're fearful that what people will do is make deals outside of their domain. If I get questions on my eBay messaging system, I'll have to delete them. I can't answer those questions. And so what we're going to do now is just go through all this material here and sort it all out. And we're going to try to refine this material for the jeweler. I've got everything sorted roughly. Here's all our stones and non-carat gold material. These are some silver pieces and some gold-filled stuff, and I'll save this and give it back to the jeweler. Down here we've got a pile of 14K material. What I'm going to do is weigh up the 14K here. And I've got some silver here that's been cleaned and ready to use for inquartation. And we'll use this to inquart our silver. So we're going to zero the container. Now what I'll do is I'll scoop the 14K material in here. Get a weight on the 14K stuff. It looks like we've got 24.8 grams of 14K. 24.8. Zero the scale. And we're going to add our 10K material now. The rest of this stuff in. Looks like we've got 19.3 grams of 10K. Here's our gold in a melt dish. So now we're going to multiply 24.8 grams times, let's see, what was 14K? 1.265. So we need 31.3 grams of sterling. For the 10K, we need 19.3 times 0.635. So we need 12.2 grams of sterling to inquart the 10K gold. I totaled these up. I need 43.5 grams of sterling to inquart this carat gold for the jeweler. I've got 43 grams over here on the scale, weighed out and ready to go. So we'll add this to the carat gold here, and now we'll take this out and alloy this metal together under the torch. Here we go. Here we go. We're in our new replacement fume hood here. I've rinsed all the tap water off of the quarted gold. Now what we'll do is add some distilled water. Now I'll add an equal amount of nitric acid. And we'll start pulling the silver and the base metals out of this alloy. And this will leave behind just the gold after we get done doing these nitric acid boils. Alright, let's set this up on the heat back here and start removing our silver and base metals. Alright, over here I've got some silver nitrate that I made for the silver cell. And as you can see, it's highly concentrated silver nitrate. Some really nice silver nitrate crystals have come out of solution there. It's high purity silver nitrate from dissolving our pure silver crystal in nitric acid to make the electrolyte for our silver cell. You may be able to tell that there's a remarkable sound difference from the old fume hood. This is a replacement that I got in about a couple days ago, and it's much quieter. Let's go over here and take a look at the electrolytic silver cell here. This thing's been running about, I guess, about 5 or 6 days. But if you look down in there, that's our high purity silver crystal that's growing inside our electrolytic silver cell. The estimated yield here is going to be about 14.4 grams of pure gold from this amount of 14K. 8 grams of pure gold from this amount of 10K. It's going to be a total of 22.4 grams of pure gold. Let's take 22.4, divide that by 31.1 grams. That's how many grams is in a troy ounce. That gives us 0.72 ounces of pure gold. This first nitric boil is boiled down pretty good. What we're going to do is we're going to add it to my silver jar over here. The silver jar is full of some sterling silver, and what will happen in there is any excess nitric acid that remains in this nitric acid boil will get consumed by the silver that's in this silver jar. The solution I'm pouring off will be concentrated silver nitrate solution. Got some water in there. I'm going to add a little bit more distilled water to that, just a little bit. And then now what we'll do, got some nitric acid over here, and we'll add an equal portion of nitric acid. And this will be nitric acid boil number 2. The second nitric boil is complete. I can tell by the lack of fume production in there when it's done. So what we'll do is we're going to pour this off now into our silver jar. Rinse with some distilled water. Now I'm adding some water before we set it back up on the heat here. I'm adding a little bit more distilled water. Distilled water provides a medium for the dissolved metals to dissolve into. I will add some more nitric acid. And this will be our third nitric acid boil. This third nitric boil is complete. You can tell by the color that we're still pulling some copper out of there. If we're pulling copper, we're probably pulling silver. So we'll rinse this out now. Solution looks pretty clear now in there. Add some water. Not much. Back up on heat. I'm gonna do one more nitric boil here. The goal here is to get all the copper pulled, and if we got the copper pulled, safe to conclude we've got the silver out of here. So we can tell when we got the copper out because the solution will remain colorless. So we'll do a fourth nitric acid boil. I think our fourth nitric boil is complete here. If you look at it, it's still got a little bit of color going on. Just a little bit. So what we'll do, we're going to go ahead and pour this out into our silver jar. Again, there's silver in my silver jar here that will consume that nitric acid that we're pouring off into the silver jar. And I'm going to do, I think we're going to do one more nitric boil until the solution remains completely colorless. Add some distilled water. Now we'll add some nitric acid. The goal here is to get the solution colorless. This is number 5. If we've got it colorless, we've got all the copper out, we can conclude that all the silver has been pulled out. Also, this is what we want to see. Colorless solution. That's our nitric acid boil number 5. Down here, if you look in the silver jar, you'll see that the silver is reacting. So what we're going to do, I've got some sterling silver articles here. I'm going to put them in this melt dish and burn it. And then we're going to add the silver to our silver jar so that we can consume all of the nitric acid that's in this 5th nitric acid boil in our silver jar. This is sterling silver that we've collected, and I've taken each of those pieces in that dish right there, and I've tested each piece with Schwerter's solution to ensure that I have silver here, because silver plated copper looks just like sterling silver. So in order to make sure I don't have silver plated copper, I file deep into each piece and add some of the Schwerter's. Schwerter's solution is a combination of potassium dichromate, about 1 gram of potassium dichromate with several milliliters of nitric acid. And we can make that and use that to test our silver. Here I'm burning it before I put it in the silver jar to burn off any combustible material before we add it to the acid. Now what we'll do is we'll pour off this 5th nitric acid boil into the silver jar. Now what we'll do is add some distilled water to the gold. Here's what it looks like. I'm going to add some distilled water and just boil this gold now in a little bit of distilled water to remove as much of the acid as we can. We've been boiling in distilled water for about 20 minutes. Now what we'll do is take this distilled water boil, pour it off into our silver jar here. All right, here is the pure gold that's left down in the bottom of our jar. Here's the recovered gold. The recovery process is now complete, and that gold in there right now is very close to 3/9 fine, just like it is. But in order to get it to 3/9 fine, what we're going to do is we're going to refine it with some aqua regia. This is a little less than 1 ounce of gold, so I'm only going to add about 100 milliliters of hydrochloric acid. Now what we'll do is add some sulfuric acid to our gold. Sulfuric acid will combine with any lead that may be present, forming lead sulfate, and then we can filter it out 100% to remove all of the lead if there's any present in our gold. Next we'll add some nitric acid, 68 to 70% nitric acid here, and this is like what we are expecting here, about 22 grams of gold. So let's go with 1, 2, 3, 4, that'll be 5 3 milliliter doses of nitric acid, 15 milliliters of nitric to form aqua regia in here. Now what we'll do is we'll set it up here on the heat and start dissolving our gold. Looks like we've still got some solids left in here. Not a whole lot, but a little bit. And so what I'm going to do, I believe, we're going to add a little bit of hydrochloric acid here to rehydrate the solution. Just back a little bit here. Maybe about 50 milliliters or so of hydrochloric acid. Just to rehydrate this and cool it off just a touch. Not a whole lot of solids in there, just a little bit. So what we'll do now is I'm going to add just a touch, maybe a half a milliliter of nitric acid. See if we can get the rest of that material to dissolve. It's quite possible that that's not even gold in there, so we'll proceed from here and see what happens. I think we've got everything that's going to dissolve to go into solution here. There might be a little bit of solid material left in there, but I don't think it's gold. I'm going to pull this down off the heat now and let this cool off. I'm going to add some ice to our solution here. This will do two things for us. It'll dilute the solution, and if there's any silver chloride in here, it will come out of solution. You can see it's turning cloudy. That's probably what's happening here. So solution's cooled off. It's got some dark material in there. Might have some other metals, platinum group metals in here. I'm going to go ahead and filter our solution now. You'll notice the color is a little off in the solution there. And jeweler's scrap, there's no telling what kind of metals are in jeweler's scrap because he works on all different kinds of precious metals, including platinum, palladium. There might be some iron in there, even some tin and lead. So jeweler's scrap is a hodgepodge of metals and can be difficult to refine. As I suspected, there's a little bit of platinum in here. Looks like the head of a ring, a diamond setting from a ring that was platinum. So that means there's going to be a little bit of platinum in solution with our gold. Alrighty, we got the first filtering complete. If you look at the solution, it's cloudy. So what we'll do is we'll set up here. We're going to pour the solution back through the same filter a second time. The second filtering passed through the same filter paper a second time. It's got our solution looking real good here, so I think we're going to be in good shape for precipitation on the next step. Here we go. We're going to get the funnel out of the way here. And now we'll transfer our filtered solution. pretty good into this beaker. Okay, here we go. First ever gold precipitation in our new fume hood. I'll put some SMB in here and precipitate out the pure gold. Just dropping in little crumbs of the SMB. As usual, I forgot to test the solution. Should always do this before we do the precipitation. This is a stannous chloride testing solution. There you can see that black stain. Means we've got plenty of gold in solution. I'm going to add another spoon of sodium metabisulfite, aka Stump Out by Bonide. One more spoon should do the trick here. I've allowed the gold to settle completely overnight, and now what we're going to do is reach in here and get some filter paper and just test and make sure that we've got all the gold precipitated. We should always do this after we precipitate to ensure that all the gold has come down. And as I suspected, you can see on that filter paper we're getting a little bit of an orange colored stain, which means that there's going to be platinum in this solution. I would normally just pour the waste solution off of our gold, but since we want to try to get a good yield for the jeweler, I'm going to filter it out into one of my specially prepared filter papers here that rides up the sides of the Buchner funnel so we can capture 100% of the solids. This is a number 2 medium flow filter. There's our gold. Now what we'll do is we'll let me get a better angle here. Filter the gold out now. Capture the gold in our filter paper. The solution is going to contain platinum, so we'll add this waste solution to our stock pot. Our stock pot is full of copper, and that little trace of platinum that's in this waste solution will cement out in our stock pot on that copper. Now what I'll do is rinse the gold up here in the funnel with some hydrochloric acid. Hydrochloric acid does a better job of rinsing dissolved metals off of the gold. I'm going to rinse it off with a little distilled water now. Here's our pure gold powder that we've filtered out of our solution. Let's see if we get some light on this thing. I have to start learning how to use the new lighting feature in here. Pure gold powder in our filter here. I'm going to take our filter that's got the gold powder in it, put it down into this clean beaker. Now what we'll do is redissolve the gold a second time here. I'm going to add some hydrochloric acid to the beaker, about 100 milliliters. I'm adding a small amount of sulfuric acid here to take care of any lead that may have made it this far into the process. Highly doubtful, but adding sulfuric acid provides a big benefit. It costs nothing almost and hurts nothing. I put a lid on it. Let's put it up here on the heat, and we're going to redissolve the gold a second time. We've got some nitric acid here. What we'll do is add about 4 3 milliliter shots of nitric acid. This will form aqua regia in our beaker, and the gold will redissolve a second time. This second refining should clean this gold up real nice for us. Looks like we've got everything to dissolve here. Let's just check the bottom. Yeah, everything's gone into solution. So what we'll do is we'll pull this down off the heat and let this cool down. Here's our solution. I've allowed it to cool off a little bit. Went and got me some breakfast. And now what we're going to do is add a few ice cubes to this to dilute the solution, cool it off, and precipitate out any silver chloride that may be present. Shouldn't be a whole bunch in here now, but we're going to add some ice anyway. And ice helps the filtering process. Alright, now we're going to filter our solution here. Most of that cloudiness comes from the filter paper that we had in there. The solution looks nice and clear, which bodes well for high purity of our gold. I've got the solution pulled through the filter. You can see it's clogged up with the filter that we added to the aqua regia. And if you look down here, our solution Looks nice and clear. It seems cloudy because there's condensate all over the flask. But I think this is a nice clear solution. It's hard to tell when you have a humid day going on and you got this ice cold liquid in here. It's hard to tell. It looks fresh and clear to me. Alright, I'm going to pull it through the same filter a second time because it's hard to tell with our flask clouding up. You can't really tell if that solution is clear in there, so we'll just go ahead and pour it through the same filter a second time. Yeah, that's high purity clear solution. Pour it back through here one more time anyway. I've nearly completed pulling everything through the filter now. Got a nice clear clean solution. What we're going to do now is I've got some copperas here. Copperas is iron sulfate. Iron sulfate will precipitate our gold, all the gold, and nothing but the gold. So I'm going to measure out about 500 grams of copperas here. The book calls for 1 pound of copperas for every 50 pennyweight. 50 pennyweight is 2.5 ounces of gold. I'm going to make enough to precipitate 50 pennyweight, even though I've only got about 22 grams of gold here. The gold has been pulled through the filter completely now. It looks fantastic, nice and clean. We'll set this back out of the way. What we'll do is we'll pull up our heating pad here, and I've got a 2-liter beaker, and to this I'm adding some distilled water. The book calls for a quart of water, so we'll add about 1,200 milliliters, I guess. Should be close to a quart. And we're going to turn the heat on down here and start heating this water up. Ferrous sulfate is very selective in that it will precipitate only the gold, all of the gold, and nothing but the gold. And we've got some platinum in our gold solution, obviously, because SMB stump out makes SO2 gas when we add it to the chloroauric acid solution, and SO2 gas will bring down or precipitate traces of platinum group metals and contaminate our gold. So when we do this second precipitation with our ferrous sulfate, the platinum group metals should get left behind in the solution. I'm making more than I need here because what I'll do is I'll save the excess or extra ferrous sulfate and use it in a future precipitation. The ferrous sulfate is fairly soluble in water, which is a good thing. And you'll notice that it turns our solution brown. I think we've got this pretty much all dissolved. What I'm going to do is add some hydrochloric acid to the ferrous sulfate solution. And what this will do is it'll cause it to turn a green color. Let's see if we can get it over here. I'm going to add about 100 milliliters. You can see it's turning green there. That's what we want to see. grab it. It's not that hot. It's just warm. So we're going to filter our ferrous sulfate solution now. Here's the book that I'm using. Right here it says, in another vessel in warm water, add about a pound of green copperas for each 50 pennyweight of fine gold that we expect. Use fresh green copperas with about a quart of water to a pound. Add a little hydrochloric acid, enough to make the copperas solution a green color. Alrighty, some folks may be asking, if ferrous sulfate is so wonderful at precipitating just the gold, then why don't we use it all the time? The answer is simple. Here's our gold solution. I've been pulling the solution through this filter up here for the last 4.5 hours. I'm still not complete with the entire amount that I dissolved in the water. And we're going to go ahead and do the precipitation now. But it takes a long time to prepare this stuff. I suppose I could prepare a large batch ahead of time and have it ready. Alright, let's see what we got in here. This is our funnel with the filter in it. That's what we've got in our filter. So we filtered out of the ferrous sulfate solution. Before we do the precipitation, we're going to get a stannous test. Verify whether we've got gold in solution. And that black stain tells us we've got lots of gold in our solution. Alright, here we go. This is the first ever ferrous sulfate precipitation in my new fume hood. I'm just going to add some of the material from our flask here. This is the ferrous sulfate going in right now. It's kind of hard to judge how much we'll need here. That hopefully should do it for us. This is not like SMB, where you can kind of tell that you've got all the gold precipitated. Let's reach down in here and get another stannous test. See if we've got our gold precipitated or not. And as you can see, that negative stannous test means all the gold has been precipitated out of our solution now. Alright, we've got our gold precipitated here. I'm going to let this settle. And what we'll do is put the funnel back in place up here and reconnect our vacuum line. And I'm going to continue to filter the rest of our ferrous sulfate up here. I've allowed the gold to settle overnight, so it has settled completely. Except for a little bit of stuff floating on top there. That's not much. So what we need to do is transfer this waste solution into my stock pot. I have 2 stock pots. This is one of them. And in here I have copper metal, and we add our waste solutions to the stock pot, and the metals will cement out on copper that I have in here. This is the waste solution from the first refining. It's going to contain platinum, so we want to add that to our stock pot. But you'll notice that it's full. What I need to do is transfer this acidic copper solution down into my waste treatment bucket. My waste treatment bucket is full of pieces of iron, and the copper in our waste solution here out of the stock pot will cement out on those pieces of iron in our waste treatment bucket. Here you can see the copper has accumulated on these pieces of iron and just falls to the bottom of the bucket. It's highly contaminated with other metals, so I don't try to recover it. It's valuable to me in that I can use the copper to cement out precious metals, but once that is complete, I have no use for the copper and I just throw it away. Got a tube of water here. What we'll do is siphon off the waste solution out of the stock pot. It's full of copper in solution down into my waste treatment bucket. Alright, this is my silver refining stock pot, so to speak. When I get done cementing silver out of the solution, I pour it into this bucket. This bucket is full of copper also, and it will cement out any remaining precious metals or silver that's still in this solution. It's been sitting here for several days. Now I'm just going to pour it right into my waste treatment bucket, and we'll cement the copper out of this solution in my waste treatment bucket on the pieces of angle iron that are in our waste treatment bucket. Cover up the waste treatment bucket, and I set this outside under a tote because it does produce some fumes and I don't want those fumes in my shop. So we'll take this outside. I've got an air bubbler here, and I just stick that wand down into the bucket. It bubbles air through it and creates some movement in there to make sure we get all the copper cemented out there on the iron. This is stock pot number 2, and I've taken the bubbler out of it. We're going to put this in my shop, covered up, and let it settle. Now I'll just set this stock pot in here, covered up, and let it settle completely. And then once all the solids have settled out, we'll siphon off the copper solution into my waste treatment bucket. Let it settle for a couple days. Now we'll pour the waste off of our gold solution here. We should have some nice pure gold down on the bottom of this beaker. Here's the gold down in the bottom of our beaker. That should be some fairly high purity gold there. Let me move this back out of the way now, and we're going to continue to work with this. I just needed some room in here to pour that waste solution off. I do have a temporary waste container. I'm just going to show you how we do this, going straight into the stock pot. This is the solution from the first refining. It's going to have some platinum group metals in it. We're pouring that in here in our stock pot that's full of copper, and that any traces of precious metals in here will cement out on those pieces of copper in this stock pot. Now we'll cover this up. Got a little notch here cut for the airline to fit through. Take this out and set it outside now. Set the stock pot outside here. I'm going to insert the bubbler tube. Just got a little air moving in there. to keep it stirred up. And then I put a toad on top of it to keep the rain off. Now that we've got our waste out of the way, just wanted to show you here, I've got our ferrous sulfate solution that we filtered, and I'll save this for a future refining. Now what we're going to do, we're going to pull our gold up here. We're going to start rinsing this off, and I'll pour those rinses off into my temporary waste container. One of these times I'm going to have to do a video, collect all that gold that's down in the bottom of my waste container, and we'll get that out of there and refine it up into some high purity gold and make a nice ingot out of that. But for now, what we're going to do, I'm going to add some hydrochloric acid to our gold over here and start rinsing off the excess ferrous sulfate that's in there. Pour off this waste. Trying to preserve as much of the gold to keep the yield as high as possible for our jeweler friend. This is the hydrochloric acid that we've used to rinse the gold. I've rinsed this multiple times with hydrochloric acid and some distilled water. So now what we'll do now is pour this rinse off into our waste container up here. Gold looks excellent. It's actually got like a red color to it. Add some hydrochloric acid here. And I'm going to set this up on the heat back here. And we're going to give this a quick boil, just like the book recommends. We've allowed this to boil for about 10 minutes. What we'll do now is pull this down. I've got some water that I've been heating in the microwave, and we'll continue to heat this so we can use it for rinse water. Some more hydrochloric acid. I've got some hydrochloric acid in my squeeze bottle here, so I don't have to dropper it in one dropper at a time. You can look and see that solution looks very clear and colorless. So I think we've got this gold pretty much cleaned up nicely. Alright, let's pour this off into our waste container. Oh yeah, the gold looks superb. Now we'll do some hot water rinses here. I'm not going to show all of this. I'll just do one for the camera. And this should rinse the rest of the hydrochloric acid off of here for us. And then we'll just add this to the waste container. Like I said, I'll do this off camera. I'm not going to bore you watching me rinse it 10 times with hot water. Let's get our gold into this melt dish now. Might have to coax it out with some water. Alright. Let's take our gold powder over to the melt table here. Wow, it's got a red tint to it, which looks absolutely gorgeous. I'm going to put this down on the melt table now and melt this up a nice gold bar. Alrighty, here's our bar of pure gold. It's got a little bit of contamination on the surface there. A little bit of a disappointment that we didn't get a nice bright shiny bar of pure gold. But jeweler's scrap contains who knows what. It's difficult to get it purified real well, and I may not have gotten all the ferrous sulfate rinsed off. We got a yield here of 21.7 grams. The estimated yield was 22.4, and 21.7 is very close. So now we got a bar refined in our new quiet fume hood, which I am grateful for. That thing is really nice, and look forward to doing many more videos in it. This will conclude the video. Thank you for watching.